In web development, creating dynamic and visually appealing websites is paramount. React, a JavaScript library, is key for building interactive user interfaces. Coupled with SASS, developers craft functional, aesthetically pleasing, and adaptable websites. React simplifies building complex interfaces with reusable components. These components are like building blocks for modular and maintainable code. SASS enhances CSS with variables, nesting, and mixins. This results in cleaner, more organized style sheets. Together, React and SASS enable developers to build responsive, stunning, and interactive websites efficiently. Before diving into React and SASS, it's essential to set up our development environment. Think of this as preparing your tools and workspace. First, we need Node.js installed on our system. Node.js provides the runtime for executing JavaScript code. Download the installer from the official Node.js website. Next, we need a package manager for project dependencies. NPM, bundled with Node.js, makes it easy to manage libraries and tools. With NPM, install Create React App to set up a new React project. Open your terminal and run the command. Finally, install SASS for styling React components. Now that our development environment is set up, let's take a look at the project structure created by Create React App. Understanding the organization of files and folders is key to navigating and maintaining our project effectively. At the root of our project directory, we'll find several files and folders. The folder houses all the project dependencies installed via NPM. The folder contains static assets like HTML, CSS, and images that are served directly by the web server. The heart of our React application resides in the folder. Here we'll find our JavaScript files, CSS modules, and any other assets related to our application's functionality and appearance. The file serves as the entry point for our application, while typically houses the root component of our React application. It's important to note that this is just a basic overview of the project structure. As our application grows in complexity, we may introduce additional folders and files to maintain a clean and organized code base. Components are the cornerstone of React development. They encapsulate UI elements, logic, and styling, promoting reusability and maintainability. Think of components as Lego bricks that can be assembled to build complex and interactive user interfaces. In React, components can be either functional or class-based. Functional components are simpler and more concise, while class-based components offer more features like state management and lifecycle methods. For this guide, we'll focus on functional components. To create a new component, we define a JavaScript function that returns JSX, a syntax extension that allows us to write HTML-like code within our JavaScript files. For example, here's a simple functional component that renders a heading. Components can be as simple or as complex as needed, and they can be nested within each other to create hierarchical UI structures. This modularity makes it easy to reason about our code and update specific parts of the UI without affecting others. Section 5. Props. Passing data to components. Components often need to display dynamic data or adapt their behavior based on external factors. This is where props come into play. Props, short for properties, allow us to pass data from a parent component to its children. Think of props as arguments passed to a function. In React, we pass props as attributes to the component when we render it. For example, here's how we can pass a prop to our component. Inside the component, we can access the prop like this. Props make our components more reusable and flexible, allowing us to customize their output based on the data they receive. Section 6. State. Managing dynamic data. While props are great for passing data down the component tree, sometimes we need to manage data that changes within a component itself. This is where state comes in. State allows components to keep track of internal data that may change over time, such as user input, API responses, or the current state of a UI element. In functional components, we can use the hook to manage state. The hook returns an array containing the current state value and a function to update it. Here's an example of a component that uses state to keep track of a counter. State allows us to build dynamic and interactive components that respond to user actions and other events. Section 7. Introducing SASS. Supercharging your styles. SASS, short for Syntactically Awesome Style Sheets, is a CSS preprocessor that extends the capabilities of CSS with features like variables, nesting, mixins, and more. These features make writing and maintaining CSS more efficient and enjoyable. One of the key benefits of SASS is its support for variables. Variables allow us to store values that can be reused throughout our style sheets. This makes it easy to maintain consistency and update styles globally. Nesting in SASS allows us to structure our style sheets in a way that reflects the HTML structure. This makes our style sheets more organized and easier to read. Mixins in SASS allow us to define reusable blocks of styles that can be included in multiple selectors. This reduces code duplication and promotes consistency. Section 8. Styling React Components with SASS. Now that we have a basic understanding of SASS, let's see how we can use it to style our React components. First, we need to import our SASS files into our React components. Create a new file named in the folder. In your file, import the SASS file, JSX import, SASS app, ESS, function app, URL. Now any styles we define in will be applied to our component. We can use all the features of SASS to style our component, such as variables, nesting, and mixins. For example, we can define a variable for our primary color. SASS primary color number 07BFF door app while background color primary color. This will set the background color of our component to blue. Section 9. Responsive design with SASS media queries. Building responsive websites that adapt seamlessly to different screen sizes is crucial in today's mobile-first world. SASS, in conjunction with media queries, provides a powerful toolset for implementing responsive design principles. Media queries allow us to apply different styles based on the characteristics of the device viewing the website. We can target specific screen sizes, resolutions, orientations, and more. In SASS, we can use the directive to define media queries. For example, to apply different styles for mobile devices with a maximum width of 768 pixels, we can use the following code. CSS us at media, max width 768 px, /container width 90%. This will set the width of the class to 90% for devices with a screen width of 768 pixels or less. By combining SASS variables, nesting, mixins, and media queries, we can create complex and responsive designs that provide an optimal viewing experience across all devices. Section 10. Further adventures in React and SASS. Congratulations! You've now embarked on your journey into the world of React and SASS, equipping yourself with the fundamental knowledge to build dynamic and visually appealing websites. But this is just the beginning. The world of web development is vast and ever-evolving, and there's always something new to learn. To further your journey, consider exploring advanced React concepts like Context API, hooks, and state management libraries like Redux. Delve deeper into SASS, mastering its advanced features like control flow, functions, and maps. Remember, the key to becoming a proficient developer is consistent practice and exploration. Embrace the challenge, experiment with different techniques, and never stop learning. The possibilities are limitless.